Okay. Thank you, Adrian, for the invitation to share our experience in Chile and how the introduction of renewable are working in our country. The necessary disclaimer that we need to show in our presentations in BHP related to the information that we will present. Well, in BHP, our purpose is to create long-term shareholder value through the discovery, acquisition, development, and marketing of natural resources. Our strategy is to own and operate large, long-life, low-cost, expandable upstream assets diversified by commodities, geography, and market. At BHP, we have an extraordinary potential of natural resources, and the role of our products contribute to advance the essential building blocks of the progress. We are among the world's top producer of major commodities, including iron ore, metallurgical coal, and copper. We also have interest in oil, gas, and energy coal. We have a global footprint with 11 core cooperated assets. This is the portfolios BHP all over the world. This is divided in 3 areas: Minerals Australia, Minerals America, and Petroleum. In total, 11 core operated assets, 7 non-operated assets, and 2 non-core assets. Going to Minerals America asset, our main copper operations are in Chile, with the mine Escondida and Pampa Norte. We are also present in Peru with Antamina, a copper mine, Brazil with Samarco and iron ore mine, Colombia with Cerrejón, a coal mine, and Canada with Jansen, a potash mine. Escondida is the largest copper open-cut pit in the world. The production of BHP Chilean asset represents 6% of the total world copper production and 18% of the total Chilean copper production. Escondida is the largest non-regulated client in the market with a peak demand of 704 megawatts. The total BHP consumption is 820 megawatts. It represents 7% of total Chilean consumption. The supply is contracted with 2 generators, Angamos, a coal-fired power plant, and Tamacaya. Tamacaya is a generator 100% owned by BHP. Tamacaya provides the supply to our asset based in a combination of gas and spot purchases. BHP is an important transmission line operator with 1,532 kilometers of lines. We have a transmission company called Kelty. Kelty manages 207 kilometers of transmission lines, 1 driver to develop renewables and transmission facilities. Then today, we have various renewable projects asking for interconnection agreements. Transmission lines are a strategic asset to enable renewable power sources for BHP. A short-term overview of the Chilean market. In 2017, the peak demand was 10 gigawatts, and the annual consumption was 72 terawatt-hour. Today, the 2 main systems are interconnected. The solar generation reached 9% of the consumption, the wind 6%, and the hydro 30%. In total, 45% of the power consumption coming from the renewables. The availability of the technologies depends on the availability of the resources. Then the non-conventional renewable resources are concentrated in the north together with thermal generation. The hydro resources are located in the center and the south of Chile. There is a large potential hydro development in the extreme south of Chile, but this kind of projects have high environmental opposition due to the areas that need to be affected and the need of very long transmission line, more than 2,000 kilometers. Chilean market is a deregulated market with 3 segments: generation, transmission, and distribution. In the wholesale market could participate only generators. The coordination of the power plant operation is centralized by the system operator, called coordinator. The dispatch is based in the merit order and variable cost of power plants. This means that the cheapest power is dispatched first and the most expensive after to fulfill the demand. The PPAs are based in the mutual backup between generators. The generators inject their power in the system when the coordinator requests, then generator purchase power from the spot to serve its PPAs. Its power could be produced by the same generator or for other generator, depending the program defined by the coordinator. In 2004, started some modification in the regulation to promote renewable. The first modification started in 2004 with a small exception in the cost of the transmission. Power plants smaller than 20 megawatt have exempted to pay partial of total cost of transmission, tolls. Initially, this initiative was focused in the run-of-the-river generation located in the mountains because the cost of the transmission was prohibited to develop this kind of project. Today, this regulation is mainly used by solar or small solar generation. In 2005, start the distribution auctions regulation opening participation to any kind of generator and with the possibility to have a long-term PPA, 15 years. After, in 2008, was introduced a law that requests an annual percentage of the energy sales to the final clients must be produced by renewable sources, like smaller hydropower, geothermal, solar, biomass, or wind. The first law put a target that to reach 10% of the final consumption in 2024. This law was after modified in 2013, increasing the percentage to reach 20% in 2025. In my opinion, the main law change was in 2014 when the authority allowed bidding for hourly blocks in the distribution auctions. In the graph, we can see how the Chilean National Energy Commission adapted the hourly blocks to the solar generation and wind to complement its production. This modification increased the interest of renewable to participate in distribution auction process because before of this modification, they need to fulfill the 24-hour supply, and now they can bid for hourly blocks. Other law modification was the introduction of an emission taxes for CO2 in emitter plants over 50 megawatt thermal. The cost of the tax is $5 per ton of CO2 emitted, equivalent to $5 per megawatt hour, US dollar per megawatt hour. Next slides show the evolution of the power price, including the energy charge plus the capacity charge. It's important to mention of energy charge represent around 50% of the end power cost today in Chile. When the Argentinian cut the gas in 2004, because we started with gas project with supply from Argentina, the fastest solution was the diesel generation. It was the most faster solution to provide the power. And in the meantime, started development of various coal-fired power plants to replace the gas generation. In parallel, the government supported the construction of 2 LNG terminals, Quintero and Mejillones, to import gas, LNG gas for cargos. Between 2008 to 2014 was the war of the coal and LNG in Chile. The prices, if you can see, raised over the $100 per megawatt hour in the energy charge, energy plus capacity charge. Prices offered in the distribution process started a reduction before the modification in 2014. the average price of the energy component reaching in the distribution before this modification was $130 per megawatt hour. In the bidding process, in 2014, the average price was reduced to $102 per megawatt hour. The last two bidding processes, the outcome were more competitive, reaching very aggressive price for the energy component for 20 years PPAs that need to be supplied since 2021 and 2024 respectively. Firming renewable is the challenge today. More flexibility in the power generation is required in order to reduce plant ramp-ups and ramp-down, overstresses, and reduce unsteadiness of the system, avoiding system cost increases such as overruns. In this scenario, ancillary services needs are increasing. The storage system, as batteries and pumping reservoirs, are required to improve flexibility of the system. The discussion today in Chile is who is accountable by this cost to firming renewables. It's one of the main discussions, and the authority is presenting some new regulation to address this problem. BHP, as I mentioned at the beginning, BHP is owned of Tamacaya. It's a generator that provide power to our asset with a CCGT project called Keller, 570 megawatts. The Tamacaya managed the production of this power plant through a BOOM contract, build, own, operate, and maintenance contract with a Korean consortium that operate this power plant and give the energy that is required for our asset. Keller Tamacaya business model allow BHP to participate in the generation market, optimizing our power cost. The model give visibility to BHP of undercover costs in the final bill. Keller provides flexibility to the system, helping in the renewable introduction. The graph in the right shows the typical operation of Keller, a daily operation of Keller. An important characteristic of Keller is the rate of the ramp-up that could provide to the system, 12 megawatt per minute. You see, Keller operates during the night and during the day when the solar generation is full, the power plant is shut down. Keller started its commercial operation by the end of 2016. The project Claveria was initially studied as a coal-fired power plant, but due to the high opposition of the coal generation, was modified to a combined cycle. Today, we can confirm that it was a good decision for the contribution of Keller to the system operation and the introduction of renewables. In terms of emission, it was a good decision as well. The Keller emission in 2017 shows a reduction of 554 kilotons of CO2 compared with the theoretical coal options. The next slide shows how its evolution of renewable in the northern grid. In 2012, without Keller, the coordinator study showed operational restriction for the renewable capacity because of the inflexibility of the system. The capacity was limited to a 750 megawatt in the most favorable scenario. In 2015, with Keller, another flexible power plant in construction, the coordinator study showed an increase of up to 1.5 gigawatt in the most favorable scenario, the double of the first study. No doubt that the flexibility of the generation was the difference. The next slide shows how is the current daily operation of the conventional generation in the northern grid, where BHP Chilean assets are located. The known dot curve appears during the hourly production, the solar production. In those conditions, coal-fired power plants are cycling as well, increasing its failure rates. The graph shows how the increase of failure rates was affecting the reliability of the final client consumption, because there were a high number of interruptions by frequency fluctuations. When killer operation started first during the commissioning stage and after in the commercial operation, the trend was reverted. Other characteristics that Keller and Tamacaya model provides to BHP Minerals America is we can supply part of our power need with renewable production purchased in the spot market. Around 50% of the Chilean asset is supplied by Tamacaya, and the supply of Tamacaya, 47% coming from the production of Keller, and 53% coming from the spot. In this 53%, the conventional generation, mainly produced by coal, provide 35%, and the renewable generation provide 18%. We think that this will continue increasing because today the only power plant that are coming in the system is renewables. Electricity represents over 70% of greenhouse gas emission in BHP. The target for BHP, as I mentioned in the morning by Kirsten, is to maintain in 2022 equivalent emission to 2017. The long run target is achieve zero emission in the second half of this century. The drivers to get it is looking for cleaner PPAs, start with fuel replacement projects, increase the energy efficiency, and offset our CO2 emission. Renewables are already competitive. Wind and solar are cheapest than coal-fired power plants. The advantage will continue for renewable due to the implementation of low-carbon mechanisms as cleaner energy targets. The coal-fired power plant will continue increasing its capex for emission control and will run less, cycling to accommodate renewables. Today, batteries seems to be the most likely solution to complement renewables. We need to follow its evolution to confirm it. In the meantime, power plants with flexibility like Keller are required to support the systems. The experience in Australia compared with Chile, I think in Australia is necessary to address the dilemma of cost, emission, and reliability and security. Renewables are now the cheapest form of new power generation. Growth in solar will depress daytime price but lift shoulder price higher. This could make firming solar more expensive in the future. As in Chile, the role of gas in the electricity market is important and changing. Purchasing renewable energy could have a material impact in greenhouse emission. However, much more is required to meet our targets. In Chile, there is a demonstrated experience in the role of the gas in stabilizing the grid and allowing greater renewables penetration. The importance of the business model decision to ensure price competitiveness and emission reduction is relevant. Chile experience provides an example that how a grid-connected mining company can accelerate the decarbonizing grid and how fast the market landscape can change. Many thanks.
So we have time for one question for Christian, if there's a question. And Arnold, you can please ask the question in Spanish, but if you could translate for us, that'd be great.
Hola, muchas gracias, señor Claveria. I will translate in English later. I would like soy responsable de los workshops antes de los congresos, entonces enseño a la gente de renovables un poco lo que es la minería. I'm responsible on the pre-summit workshops, and I'm trying to explain to the people of energy on the energy side, what means energy? Sorry, what means mining? So in that case, one of the typical things they ask me is about the desalination water and pumping water in Chile. Mm-hmm. If we could explain a little bit, because I think in Australia they will have the same problem in future, and that affects a lot to energy. Capito, no?
Perfect.
Okay, gracias.
Yes. There is a regulation in Chile that avoid that new projects use fresh water in the operation. Then all the new expansion or new projects in the mining sector need to be supplied by desalination water. Desalination water is a very intensive project that requires power. Then today the situation is how the increase of the consumption in the mining sector could be addressed these needs. And today, for example, this is not necessarily only to fulfill the demand of desalination. Not only that, in addition, you need to fulfill the demand of the pumping of this power production. Unfortunately, all the mining that we have in Chile are in the mountains, and we need to pump 2,000 or 3,000 meters over the level of the sea to reach this water in the operation. And these are very intensive needs that the mining need to address in their projects and to solve this issue. Mm-hmm. Okay.